Hello again, I'm Dezz Asante from the TechMuze Academy, and welcome to another mixlessons.com video quick tip. This is a little tip that will hopefully help you to better understand the tools that you're working with when it comes to your own home music productions, and in particular, your microphone collection. So basically, in my opinion, your microphone choice, when you're going to record something and you've got, say, 5 or 6 mics in your collection to choose from, the mic you choose, in my opinion, is your first EQ decision. It's the first thing that's going to help you shape the overall end result tone of the signal you're trying to capture. So it's important to get familiar with the frequency response curves of your microphone collection so that you can more quickly reach for the right tool for the right job to get the sound that you're going for in your head to come out of the speakers, of course. Okay, so a little technique that I've stumbled upon that I think is pretty useful when you have some downtime in the studio is to actually run what I call the pink noise mic test, so that you have a chance to A/B your microphones and get familiar with what they're doing to the tone of your signals. Okay, let me pull up Cubase and show you exactly what I'm talking about. Now, what I've done here is I've got, what do we got? 1, 2, 3, 4, 5, 6 microphones from my collection that I have run this test on. And let me explain what I've done. Basically, what I've done is I've got a pink noise generator. A noise generator is pretty common to almost any digital audio workstation. I'm a Cubase user. In any DAW that I've ever worked with, there is some kind of signal generator. So what I've done is I've set it to generate pink noise. I've turned one of my speaker monitors off, so only one speaker is firing. And I've placed a microphone in front of the speaker and measured the distance so I can keep control over this little experiment. Okay, so with the speaker producing pink noise and the microphone measured in my particular case 6 inches from the speaker cone, I would record a few seconds of that sample. Then what I would do is I would switch out the microphone, keep everything the same, put the new microphone on the stand, readjust my distance so that the capsule is exactly 6 inches away from the speaker cone, and I would use that microphone to record the exact same pink noise signal. And I did the same thing for every microphone here in this little experiment. What this does, pink noise, for those of you who don't know, is basically all of the frequency spectrum being produced simultaneously, and it just sounds like static, okay? But what this does is it allows me to A/B back and forth between my microphones to be able to find out what the difference is between them, tonally speaking, frequency response wise, okay? So let's have a quick listen. So the first microphone in the experiment was the Shure SM7B, still to this day one of my absolute favorite microphones. It's a large diaphragm dynamic mic, and when it captures the pink noise, it sounds like this. Okay, second microphone in the collection is the Rode NT5, and it sounds like this. From there, we have the Audio-Technica AT4033, and it sounds like this. Then we have the less expensive Audio-Technica AT2020, and it sounds like this. And then I have an inexpensive Apex measurement microphone, and it sounds like this. And then I have a CAD Trion 7000 ribbon microphone, and it sounds like this. So the difference with the ribbon microphone is the most obvious and apparent because of the nature of ribbon mic technology. Ribbon microphones always have a more warm, round sound, less high frequency response, okay? Typically speaking. So now let me just get the system playing, and I'll quickly move between the microphones so that you can more easily hear what the frequency response differences are between these mics, okay? So again, we'll start with the SM7B. I'll just keep it playing and I'll flip through the mics. In fact, I'll let you see over here exactly what which mic we're dealing with, okay? So check it out. Okay, so hopefully you find this little trick useful. Now, what you'll start to do is once you A/B back and forth between your mics with this same signal, this same even distribution of all the frequencies in the spectrum, you start to get a little bit of familiarity with the tonal response of each of your microphones. And then when you apply that to your decision-making process when you're actually recording signals, live audio, you'll start to begin to hear this correlation. When you hear that Trion 7000 has a very kind of muffled, kind of very muffly type sound to the tone, sometimes that's appropriate. Maybe you're recording something like, say, for example, a violin that has a very shrill, almost piercing sound depending on how it's played and the instrument itself. You may want to offset that a little bit by using a microphone that's a little bit less sensitive to those frequencies. I might reach for that Trion 7000 and give it a go and see if it does what I expect it to do. Maybe you want something that's a bit brighter, that has a bit more of the upper frequencies to draw out that from the sound you're trying to record. Well, then you can quickly refer to this little experiment and very, very quickly know which microphone is going to do that the best. Try it out and decide for yourself. Let your ear be the judge if indeed it's the right tool for the job. So remember, your your microphone choice is your first EQ decision in the signal chain throughout the production towards the end of the mix. Very first thing is, well, of course, very first thing is the source itself, your instrument, your voice, your what have you. The very next thing in line is the microphone you choose and the way you position that microphone to capture the sound. And like I say, that mic choice is, you can consider it your first EQ decision. That's what will guide your decision-making process. And hopefully this little experiment, if you run it on your own mic collection during some downtime, will help you to make that decision quicker and more accurately to achieve the sound that you're looking for. Okay? So hopefully you find that helpful, and we will see you on the next quick tip.